Students, today experiment number 5, slump cone test. So this is small diagram of slump cone test. The bottom diameter is 20 centimeter and the top diameter is 10 centimeter and the height of the slump cone is 30 centimeter. So if you take radius is equal to d by 2. So it becomes 5 centimeter small. This is taken as small r. This is radius capital R taken as 10 centimeter. So height is 30 centimeter. First we'll find out the volume of slump cone. We have a formula for volume of slump cone. Pi h by 3 r square plus r plus r square. So if you calculate this, so if you solve this equation, you will get a value of so here pi is 3.14. If you solve this equation 14, you will get 5495 centimeter cube. If you convert this centimeter cube to meter cube, 5495 into 10 power minus 6 meter cube. This is conversion for centimeter cube to meter. 005495 meter cube. So this is the volume of the slump cone. So we have a formula. So density is equal to mass by volume. So this formula will be used. We are going to use it to find out how much mass we require for this slump cone test. So mass of the concrete. We are going to determine mass of the concrete. How much weight of the concrete we have to take. So we know the density of concrete. Density of concrete is 2400 kg per meter cube. You know the volume. So by this you can calculate the mass. So mass will be 2400 kg per meter cube multiplied by 0.005495 meter cube. Meter cube is will go. So we solve this 2400 multiplied by 0.005495. It is 13.188 kg. So this is the weight of concrete we got from this calculation. So we'll consider some wastage. So when we are doing this experiment, we'll have some wastage of concrete. We'll take wastage of concrete 50% of this weight, 15% of 13.188. So that is 6.594 kg plus 13.188 kg. This implies 19.782 kg. So round this and take 20 kg of concrete to conduct this experiment. So as per the first step, take 20 kg of concrete to conduct this experiment. The experiment we have to take 1:2:4 concrete of 20 kg. The weight of 1:2:4 concrete is 20 kg. Now we have to determine mass of cement, fine aggregate, coarse aggregate, and water. So we have a small calculation to find out this. So to find out the amount of cement, fine aggregate and coarse aggregate, we have a standard formula. So to find out cement weight, 1 plus 2 plus 4, if you calculate this total weight is 1, 2, 4 is 7. So cement proportion is 1. So mass of cement can be calculated as 1 by 7 multiplied by total weight 20. So if you solve this, 20 divided by 7, this is 2.85 kg. So we have a standard equation that 1 plus 2 plus 4 concrete, you add 1 plus 2 plus 4, which becomes 7. So mass of cement is 1 portion, so 1 out of 7, 1 over 7 multiplied by 20, 2.85 kg. So for the same, if you want fine aggregate, to fine aggregate it is 2 by 7 multiplied by 20. Again for coarse aggregate it is 4 by 7 multiplied by 20. So here mass of cement is 2.85 kg. Mass of fine aggregate is 5.7 kg. Coarse aggregate is 11.4 kg. So now we have to determine the weight of water. So first step is we have to take water cement ratio as 0.5. So 0.5 means 50%. So here the 50% of cement, it is 2.85. So 2.85 we have to take 50%. It is 2.85. It is 1.425 kg. So the weight of water, we have to take weight of water is 1.425 kg. So these are the weights: 2.85 kg, 5.74 kg of fine aggregate, 11.4 of coarse aggregate and 1.45 kg of water. With these we will mix a cement proportion. I will show it to you in the lab. From the calculations, we will take cement, fine aggregate and coarse aggregate and water. The weight of cement is 2.85. It is already measured. The weight of cement is 2.85 kg. The weight of fine aggregate is 5.71 kg. The weight of coarse aggregate is 11.4 kg. And the weight of water is 1.425 kg. Okay. These are the equipments we are using for this experiment. This is the slump cone which we are going to use for the experiment, and this is the machine mixer which we are going to use it for concrete mixing. So we will prepare 1:2:4 concrete with 0.5 water cement ratio. That is, we have already weights of that. So now we are going to mix a 20 kg of concrete by this machine. We have to drop the coarse aggregate. After that, you have to take the fine aggregate. Once you drop coarse aggregate and fine aggregate, we have to on the machine for a uniform mix of this coarse aggregate and fine aggregate. Show it here. Okay. After 30 seconds of mixing, now add cement. Dropping cement, we just turn on the machine, and when it is mixing, we'll add water step by step, or gradually we'll add some water to the mix. after mixing it for 3 minutes, you just drop it onto the tray. You should mix for 3 minutes. Turn on. So now concrete is ready. We have to drop this concrete into this cone in 3 layers. First fill up to 1/3 layer and 25 times we have to tap this with rod as you done in previous bulk density. Again fill 1/3 and tap it for 25 times, and again fill the top layer at 25 times, then level with this tapping rod. So before starting the experiment, you should clean this slump cone test, and the inside of the slump cone should be very clean, and apply a lubricant oil to the total surface of the slump cone. Why? Because this concrete does not will get struck to these sides, and whenever you are doing the experiment, you have to make this machine mix also wet before doing the experiment, because it does not affect the water cement ratio. So everything has to be made wet. All surfaces using for this experiment has to be in wet condition. Once everything was set, just lock the equipment. So this is the lock system we are having. Lock the equipment. And now first fill up to 1/3 layer. After filling up to 1/3 layer, tap it for 25 times. Now fill again remaining 1/3 layer. So when you fill up to again 1/3 layer, again tap it with 25 times. Okay, now full this top full up full layer. Okay, wait. Now again 25 times. Now complete this, fill it up to this top part. So once it is done, now remove this slump cone. Remove the lock. This one. That one. Once you got slump like this, we have to measure what is the height of the slump, right? So if you measure it like this, okay, from here. So when you do with 0.5%, you may not get a heavy slump, but when you do with 0.6, you will get true slump. When you will do with 0.7 water cement ratio, you will get shear slump. When you do it with 0.8, you can get this collapse slump. Once you have done the experiment, you have to fill these calculations, observations and calculations. Write down the weight of cement, weight of sand and weight of aggregate. You can take this 0.5 water cement ratio and after calculation write weight of water here. Weight of water of 0.6 water cement ratio, 0.7 and 0.8 water cement ratio. Note down the slump heights you observed for different water cement ratio. Once you have added 0.5 water cement ratio, then add 0.1% because already 0.5% is there. If you add 0.1%, it becomes 0.6%. That's where you have to fill this results table. Once you have done with this, you have to plot a graph between water cement ratio and slump cone. You come prepared to the class like calculating the weight of water at home itself, so then you can directly do the experiment. Generally, if you do with 0.5 water cement ratio, you may not observe a slump there. From 0.6, 0.7, 0.8, you can observe different types of slumps.